Have you ever wondered how the universe works? In 1900, Lord Kelvin made a bold statement that there was nothing new to be discovered in physics, only precise measurements. Picture a world on the cusp of a new century, the year 1900. Lord Kelvin, a physicist of great renown, confidently declared that the universe had no more secrets for physics, only the refinement of measurements. But, as is often the case, the universe had other plans. Within the span of 3 short decades, this statement would be challenged, and not just lightly, but profoundly. 2 new theories would emerge, shaking the foundations of our understanding of the physical world. These were quantum mechanics and Einstein's theory of relativity. Quantum mechanics, with its wave-particle duality, introduced the idea that particles could exist in a state of flux, behaving both as particles and as waves. This was a mind-bending concept that defied conventional wisdom and upended the deterministic world of classical physics. Meanwhile, Einstein's theory of relativity painted a picture of a universe where space and time were intertwined into a 4-dimensional fabric, bending and warping under the influence of massive objects. This groundbreaking theory not only challenged Newton's laws of motion, but also gave us a new understanding of gravity. These 2 theories, each revolutionary in their own right, didn't just add a few new lines to the book of physics, they rewrote entire chapters, igniting a cascade of profound questions and mysteries. They opened up a world where particles could be in 2 places at once, where time could slow down or speed up, and where the fabric of the universe itself could bend and stretch. So, as it turns out, the universe held far more secrets than Lord Kelvin could have anticipated. Now imagine a force so mysterious and powerful it makes up about 95% of our universe, yet we can't see it. We're talking about dark energy and dark matter. Let's begin with dark matter. The concept was born out of an astronomical puzzle. When scientists were studying galaxies, they noticed something peculiar. The force of gravity, generated by all the stars and gas we can see, wasn't strong enough to hold the galaxies together. So they proposed an invisible substance we now call dark matter. Although we can't detect it directly, we can observe its gravitational effects on the visible universe. It's like a ghostly hand, silently shaping the cosmos. Now, onto dark energy. This is an even stranger concept. In the late 90s, astronomers made a startling discovery. The universe wasn't just expanding, it was accelerating in its expansion. This was completely unexpected. According to the laws of gravity, the expansion should be slowing down. To explain this phenomenon, scientists proposed the existence of a mysterious force working against gravity, pushing galaxies apart. This force is what we now refer to as dark energy. These twin mysteries, dark matter and dark energy, have changed the face of cosmology. They've challenged our understanding of the fundamental forces of nature and caused us to rethink our place in the universe. Despite decades of research, we're still not sure what these enigmatic entities are made of. Are they exotic particles we have yet to discover, or do they represent new, unknown laws of physics? The search for answers continues, with scientists around the globe striving to unlock the secrets of the universe. Telescopes are scanning the skies, and deep underground detectors are waiting for a hint, a whisper, from the elusive dark matter. And so, we find ourselves in an exciting age of discovery, where the mysteries of the universe are being probed deeper than ever before. Yet, despite our best efforts, the true nature of dark energy and dark matter remains a mystery. What if time doesn't always move forward, and what if our universe isn't the only one out there? These are the fascinating questions we're exploring today. Let's start with the arrow of time. In our everyday experience, time moves in one direction, from the past to the future. This is so fundamental to our lives that it's hard to even imagine it could be otherwise. But in the strange world of quantum physics, the arrow of time doesn't always point in the same direction. In fact, some experiments suggest that particles can move backward in time, overturning our conventional understanding of cause and effect. Now, you might be thinking, that's all well and good for tiny particles, but what about the universe as a whole? Well, that's where the concept of parallel universes comes in. According to some interpretations of quantum mechanics, every time a quantum event happens, the universe splits into multiple versions, each with a different outcome. This means that there could be countless parallel universes out there, each as real as our own, but following a different path of history. But how can we make sense of these mind-bending ideas? Well, one way is to think of them as challenging our perception of reality. We tend to think of time as something that flows, and the universe as a single, unique entity. But maybe time is more like a landscape with different paths leading to different futures. And maybe our universe is just one among many, each with its own laws of physics and its own history. Of course, these are just theories. We don't have any direct evidence for backward time or parallel universes, but they offer intriguing possibilities for explaining some of the mysteries of quantum physics, and they push the boundaries of what we can imagine.